Okay, so we're going to take a look at pyramids and cones. All right, so let's take a look here. So we're going to differentiate between a prism and a pyramid, right? So before we took a look at cylinders, but also we talked briefly about what a prism is, right? Something that had some kind of polygon as a base. In this case, the triangle. We could think of a base, and then some kind of height, right? And each kind of slice that's kind of parallel to the base has that same polygon throughout the whole height, right? So each, and here, let me just, right, no matter where I slice it here, right? That intersection there that we see there, right, is the same shape as the base, right? So that was a prism. Right, now we're going to take a look at a pyramid here, and now you notice the difference. Right, now it still has the base. Now this is the same type of pyramid, same base as the prism. Right, now the pyramids will be classified by whatever shape the base is. So this would be called a triangular pyramid. If the base was a square, then we called that a square pyramid. Right, if it was a pentagon, right, five-sided polygon, pentagonal pyramid. Okay, now while these look, so the main difference here is that instead of having some height that goes straight up, this point G, right, is what we call the vertex. Right, so all of these sides here kind of meet at this one point, right? All of the vertex of the base of the polygon, right? You extend the line segment to reach a point above the one point that is above the pyramid. Right, now it doesn't necessarily have to be like on the center, right? I can kind of move this around here, right? And it still is a pyramid. Now, while this looks very different than our prism, they are, in a sense, they do have some kind of relation between both of these. Right, now here you see both of the figures. Let me move this G here. Both of the figures, one inside the other. Right, now, as it turns out, their formulas for the volume are related. Right, now, if you recall, for the prism, the the volume formula is the area of the base times the height. Now, as it turns out, no matter where this G, whether it's something like this, all right, and you notice that kind of how it looks here, or if you kind of move it anywhere, anywhere along here, right, you notice there's a corresponding change in the orientation, the shape of the pyramid. Still triangular base, still a pyramid, right? But as it turns out, all that empty space that you see there, right, is actually 2/3 the volume of the prism, right? Which means that our volume formulas for a pyramid is whatever the area of the base is, and then you divide it by 3. Right, so the pyramid is 1/3 of the volume if it were to have the same base, but instead of a pyramid, be a prism. Right, so that's the formula that we go with. Right, now the volume of a cone, so the cone is you can think of a very specific pyramid, right, where the volume of a cone has a circular base and is still the same idea where all around the sides reach up to one point vertex above the base, right? And I know I can use the same formula here, but what is the area of a circle? It's pi r squared. So the volume for the cone would be pi radius squared h over 3. Okay, so let's kind of just jump into a problem here. Right, so for this problem, we would like to find the volume of a square-based pyramid with a vertex in the center of the square, such that each triangular base has a base of 12 inches and a height of 10 inches. Okay, so a nice visual would help here. So let's see here. Let's turn these off here. All right, and here. So this is the type of pyramid that we're working with, right? Not to scale to the numbers that were given to us, but it gives you a nice idea, right? The base there is a square, right? The vertex is directly in the middle of that square. Okay, so that's going to be helpful here, right? Now notice here that as we extend from the corner up to the vertex up here, each one of these what we call faces, right? So we have the base is the square, but the faces that kind of lead up almost like tiles onto the vertex, those are all triangular. And that would be the case for any pyramid, right? Those faces will all be triangular, right? And that's the information that we know, right? Notice what we're gonna need here. We're gonna need the area of the base. So here, let me switch over here, right? So the volume of a cone is area of base times the height over 3, right? Since we're dealing with, excuse me, the area of a base is the square, so whatever the side is squared times h over 3. Okay, so I know here, right, the base looks like this. Excuse me. The base looks like this, and this is what one of the faces, that's what it looks like, right? And they tell us something about the base, right? The base, this triangular face has a base of 12 inches and a height of 10 inches. Now, this does not tell me the height of the pyramid, right? This is what we call the slant height, right? If you go back to right, so that what we have here, that 10 is the distance along here, from here to here. All right, from the base here up to the vertex. All right, so the height would be from where we see this blue axis straight down through the center of that circle, right? Which I don't know, but I can find using some triangle geometry here, right? So if the base is 12, that is this base that goes along here, right? So that is essentially what the sides of the square are, right? So what we have here is, so this will be 12, right? Right, so again, this is the base of my pyramid. Okay, now what I would like to find next is, well, what is the height of this pyramid? That's going to require, right? So notice here, that would be the height here along that blue axis. No, ignore the numbers. This is not to scale, right? So it's not the same figure. It's just here as a reference point, right? So if it's right in the center, that means that I know what the length is from here, the center of the square, to the edge. Right, if it's right in the center, the whole length is 12. That means half of it would be 6, right? And I also know, so here, what I really want to know here is if this is the top. Of my pyramid, I need to know the height. But I do know the slant height, right? That's going to be 10, right? That is that 10 from the height of that triangular face. But I also know this height, right? That's half of the base, right? That is 6. And if this is the height, that means that the perpendicular drop down makes a 90-degree angle. Okay, well, now I can use my Pythagorean theorem here to find the height, right? Remember, h is one of the legs, right? 10 is the hypotenuse, so we get 10 squared equals to h squared plus 6 squared. So we get 100 equals to h squared plus 36. Subtract 36 from both sides, and we see right away we get h squared equals to 64. Take the square root of both sides, and we get h is 8. All right, h is 8. All right, so now I have all the information that I need, right? I have the area of the base, and now I have the height. So the volume will be 8, which is the height, times the side squared over 3. Plug this into my calculator. We get 8 times 12 squared over 3. And we get 384. And again, as always, when dealing with physical quantities, do not forget the units, inches cubed.